and welcome to our panel session on harnessing the power of digital transformation. My name's Sam Ridsdale and I'm a Global Account Director here at Hitachi ABB Power Grids. We've got a fantastic panel for you today. I'm joined by Theodore Johnson, by Ralph Graf and by Kari Suominen. We're going to be discussing the different routes towards operational autonomy, the faster time to innovation and the ability to harness the right data to make intelligent decisions about your businesses. So firstly, let me just introduce you to our speakers. Delighted to be joined by Kari Suominen, who is the Chief Information Officer at Fingrid. Kari sits on the board of Finland, as well as the Digital Committee of the NSOE. Also delighted to be joined by Theodore Jonsson from Landsnet in Iceland. Theodore is an asset and digitalization engineer and is busy designing and integrating digital substations across Iceland right now. And last but not least, of course, Ralph Graf, who is our global digital leader here at Hitachi ABB Power Grids and looks after digital for all of our HV products. So welcome to the audience and a warm welcome to our panel members today. Thank you for joining us. First of all, I'm going to ask each of the panel members to spend a couple of minutes talking to you about really what digital transformation means to them and how they are currently harnessing the power of digital transformation in generation and transmission. So first of all, Kari Suominen, over to you. Thank you.
Thank you. So at Fingrid, we have included digitalization in our strategy already a couple of years, but that was the time we were not so sure what would that mean in our business. But during a couple of 2 years, I would say, we really have worked on the topic and made it defined what digitalization means for transmission system operation and especially for Fingrid. In Finland, we are now having a very huge boom on renewable energy. Today, we have around 2.5 gigawatts of wind power installed, but we have projects worth of over 120 gigawatts, so huge amount of wind power coming to our network, to our grid, and it changes very thoroughly the way we operate our grid, we operate our markets, and how we operate our assets. So very thorough change in our business.
Thank you, Kari. Thank you. That's a huge increase in renewable generation then that Finland is looking at over the next few years.
Right.
So Theodore, over to you then. What are you guys doing in terms of digital transformation at the moment?
At the moment, we are taking a decision that we are only building a digital substation. And right now we have 7 digital substations up and running. And we are trying to be more specific what we want. And we are facing problems, not problems. We are the leaders right now in digital substation, and now we want to improve ourselves with assets data from the digital substation. We want to have it in the cloud, and we are thinking, why not connect one digital substation to another digital substation? And we are just going for the digital. That's the future. Like we say, the engineer, why not go on the road? Why stop?
Of course, and that's a very bold decision for Landsnet to make that you're only going digital in the future. That's very exciting, but I'm sure it brings some engineering challenges for you along the way.
Lot of engineering challenges and lots of new thinking, because you have copper wires, now you have some process bus, station bus, you have flexibility that you never foreseen before, and it's very exciting.
Superb, superb. That is great. And Ralph, from your perspective, then obviously you're at Hitachi ABB Power Grids, but what does this digital transformation mean to you?
Yes, let me share a couple of slides, and please let me know when you see it.
Perfect.
So what we have a very long experience in Hitachi ABB Power Grids with digital substations. So we started somewhere back in the late 90s to deliver equipment for digital substations to our customers. Now, in the recent years, there is, let's say, really a pull towards operational business for digital substations, while in the past we had mostly pilots. Now, the demand is, let's say, increasing quite a lot around delivering and energize the substations faster, being more flexible, providing more safety, especially working safety is a huge topic. Then, of course, we want, there is a demand to minimize the equipment stress or to also to lower the stress to the grid. But also to minimize any outages, to be faster in planned outages and to avoid the unplanned outages, to save unproductive time, and also to come more to remote inspection and remote services. And with digital equipment, especially in the high voltage area, we are providing we are answering this demand with increased value in effectivity, safety, reliability, and availability. And now, looking to our portfolio, and I don't want to go here into the details, we are splitting our portfolio nowadays in 4 different sections, like smart design, where we are able to use augmented reality to place CAD models in a real environment. We have remote services where we talk about remote support, remote monitoring, collaboration center, which is a kind of service call center, and remote factory acceptance tests. Then we talk about smart monitoring, where we connect to all assets monitoring devices, which are communicating their data to connected software. And finally, we talk about digitized high voltage equipment like full digital control, point on wave switching, low power instrument transformer, and motor operated circuit breakers. And those different portfolio streams provide, again, values which you see here. The second big part in high voltage products are processes, and of course the external processes on the right side are focusing on ease of doing business with our customers, and we want to reduce complexity, we want to increase business reliability, and have a high focus on safety and quality. So that at the end of the day, we want to solve the customer pains, and we want to support our customers that they can do their business in a better way. Now, internally, of course, we are supporting the external processes. We want to be a reliable partner, having, again, a high focus on safety and quality. We harmonize processes and tools, and we are focusing on transparency and reliability. Thank you.
Perfect. Thank you for that run through, Ralph. That's really interesting. Now, I guess thinking about all of the challenges, and we've got 2 Northern European TSOs with us today. Carrie, what do you think are your top 3 focus areas in terms of digitization at the moment? What are the 3 things you're really looking at Fingrid?
Right. That is a very, very good and challenging question, because the digitalization, as I told a couple of years ago, we didn't know what digitalization could mean. But today we understand that it means everything for us. And having some prioritization there is a must. And first of all, we think about the data management as such, the culture and processes in data management, because data is core here. As a TSO, we collect lots of data from different devices, and we also take external data. So how to manage that data? Who is owning the data? Who is taking care of the quality of the data? We also need to take into account GDPR related things and so on. So the data management as such is a very huge thing, and we have taken this very seriously. We have worked for 2 years now, basically, with the data management, and have received pretty good results there. The second thing is the data platform and the real-time data management capabilities, because storing of data, creating APIs, micro solutions, this is completely new for us. Earlier, we relied on basically software from the shelf, so ready-made software. Today, majority of our software is made from scratch. So we collect data, we create integrations, we do APIs and micro solutions for our purposes, and that is the very huge thing. There are new technologies coming and how to work that we are not able to hire people into our own organization, but how to get the best skills to provide those solutions for us, what we need. And that has increased the cooperation or enabled the cooperation with business. So we need to have ideation with business from very beginning into the whole life cycle of the solution, through the development and through the usage of the solution. So this is very close cooperation with business all the time. And sometimes I say that we have 300 software engineers in our company. Some say it's shadow IT, but I call it bonus IT, because we create together new things. So that is the second thing, data platforms and real-time data operations. Real-time data operations, because we are going into renewable energy, and we really need to operate in real time, get flexibility, get reserves on time, and so on. So we really need those capabilities. And the third thing is the automated maintenance of the grid. And there we come to digital substations. As such, we have today 115 substations. So, of course, it's not possible to change those substations with digital components, because it's a huge amount, and the lifespan of a substation, we are talking about tens of years. So we started to digitalize our old or conventional substations with equipping those with, say, 500, 600 sensors, where we measure different parameters like sound or voice of this audio of the switches. We measure temperature, we measure time, and through the analytic tools, we are able to see what is possibly happening in the substation. In parallel, we are piloting real digital substations with real digital components, and that is a learning curve for us, of course. But our target is to go towards automated substation maintenance, so that we do not use calendars when to go to check the condition, but the substation sends alarms that something might happen there, and our outsourced service providers then go to the substation and check the condition. So that is one very big and interesting thing, and also very much related to data management, data analytics, and also operative data analytics. So combination of different things.
Super. So data is a really big thing for you, along with the platform, and you guys are creating a lot of these APIs and microservices yourselves. But yeah. I noticed that you said that you have 300 software engineers, so it sounds like your organization is really engaged with the digital transformation that you're going through. Is that fair to say?
Exactly. Yes.
Fantastic.
Kari, can I ask a question?
Sure.
The data platform, are you owning this data platform, or are you renting this data platform?
The data platform is ours, but we are combining. We have kind of hybrid. We have on-prem services, we have cloud services, but the data technology is ours.
Okay.
But there are lots of external service providers developing and supporting. That's another interesting thing, because the usability of software in TSO is something else than in the, I would say, conventional industry, as an example, because before the SCADA was the one and only. You need to have very high availability, but now more and more software are so critical that their availability needs to be on the same level, and that's also one very interesting challenge, how to provide those services in the very new type of solutions.
I could see Theodore nodding at that point, Ali, when you were saying that SCADA was used to be the only important thing. What's your view on that?
My view is that, like Fingrid is doing, that you have to go and we have to manage our data better. That's a project that we are starting here at Landsnet. Who owns the data? We have to find the right way to store the data, to visualize the data, use some AI, something to help us reading out what is in the data, finding if there's a failure in the component, the circuit breaker, or the asset that we own. And my question to Kauri, do you use some with like open source platforms, or is only made by Fingrid?
Today we do not use open source yet. We use basically Microsoft-based solutions, Azure and lots of Azure and Microsoft stack. But we are following some TSOs in would say Western Europe are very keen on utilizing those open source solutions, and we are also following what is happening there. Maybe some kind of cooperation could be possible in the future.
Yeah, it's a good one. I think my opinion is that open source is very good for this industry, and maybe we have to have an open source platform for TSOs.
Sure, it certainly sounds like collaboration is something that we're all going to have to think about, because I guess countries around the world are going through very similar journeys to you. Theodore, I mean, do you have any particularly different challenges that you guys are thinking about from Kari?
Yeah, we have, if our focus is not the same now, but we are, like I'm telling, we are focusing on the digital substation, and we are building digital substation, and that's mainly because we want to have the substation take less space, and the operation cost for the substation is less because we have less space, we have less room to heat up, and also environmental to use less copper. And the most challenge for us is we have to go to the substation, and this can be a pretty long drive to a substation remotely. So we want to have remote access, can make remote tests just here in the office and see the data coming through to the office. That's one of the, And then we see with digital substation that we have more flexibility, because we can, like the next topic, smart grids. If we have digital substation and everything digital, we can make better smart grids. We can take the technology to increase the customer stability, reliability of the system. And we have a project here that we have wide area control, that we are just using digital signals to decide what we want to do if we have a disturbance in the system.
Okay, all right.
Then the next one is like the Fingrid. We want to have IoT, the cloud, and this journey is just, like I say, it's just starting.
No, I mean, you have to start somewhere, I guess.
Yeah.
And so it sounds sometimes, people might think that building a digital substation is going to be a little bit more expensive than building a standard one. But it sounds like you guys at Landsnet have managed to make the business case for doing things remotely. So are you finding that there is truly a saving in terms of the operational expenditure for you?
I think so, but we have, just like I said, it was just last year we advertised, I think 6 or 7 digital substations. But we find after after each year that we have more better solution to what we want in a digital substation. The cost of the substation is going down because building a house in Iceland is very expensive. If we can minimize the houses, then the cost is going down. And like just because we don't have to have so many copper wires to put in a LCC cabinet. There's so many things.
Okay, it's all complicated together.
Yeah,
for sure.
Yeah.
And so, staying with you, Theodore, if you don't mind, what's your experience with the digitalization of HV switchgears? Then, do you think that they're valuable, and do you see any changes that you require to the portfolios that we have today?
Our experience now is very good. We have most of our GIS has a NTS. Low power voltage and measurement, and like I said, we think is a better solution. It's we have like CT and VTs, they are linear, and then we come into personal safety. We don't have current circuits that you can open, and it is very dangerous. And what would you like? We were talking about this. We want to have more digital in the GIS. We want to have the LCC cabinets. We don't want to have copper cables to the LCC cabinets. We want to have the switchgear, the drives, digital. That's my mission to seeing that we just, when I get GIS, I just plug in the one fiber and I have all the data.
That sounds fantastic. We hear you loud and clear, Theodore. Thank you. Ralph, what do you think of Theodore's challenge for everything to be digital?
Yes, there is a way to go, let's say, but we are prepared. As I said earlier, I mean, we have a very long experience back to the late 90s. And when I look back, I was not in high voltage, but a lot of colleagues are still there. Of course, the product costs were typically quite high. So the value, especially when we go a long time back, the value was difficult to meet, just due to the high product costs. But now we can ask ourselves, why were the product costs relatively high at that time? And there are multiple reasons, like, for example, on the technical side, but also on the commercial side. So electronics have developed, digital performance is today much different than 30 years back. And of course, also the requirements have increased in the meantime. So there are pros and cons why this was not so let's say, possible in the past. Now, since some years, we have a high focus on digital due to the market pull to help our customers. And this, as I have shown in the slides, has a big variety and we have already products in the digital field which have a high, let's say, market share, a high delivery share. So things like, for example, point-on-wave switching and monitoring is something what we very, very often deliver together with our products. And there are others which still need some development. And the reasons why we still need some development in the sense of market ramp-up of volumes, delivered volumes, these are because they were developed just some let's say, weeks or months ago, or maybe some years. Others, there are still development efforts needed. And when I touch, for example, remote services with augmented reality, where we provide a solution where our product experts see what the site technician can see in a one-to-one directly in real time, this is an amazing technology which is available now. And we are, let's say, talking to customers to use it and to get in touch with us. So, our collaboration centers is a new topic where we have 5 collaboration centers around the world where all the substation data come in, and the product experts, they sit there and talk to customers to help them to minimize the shutdown times and to help with problems. And then, of course, all these digital products like low power instrument transformers, full digital control, software products, cloud solutions, they are in the moment in a huge development where we just will provide also in the recent future very good developments and product portfolio.
Okay, so exciting times still to come,
Yes.
Ralph. Then. Super, thank you. Kari, thinking back to what you said at the beginning, that in Finland you're looking at more than 5 times more renewable generation in the future than you have today. We sometimes hear that in other countries that can cause some challenges around power quality, around harmonics and such like. Do you think that digital technology can help more than conventional technology in balancing out some of these power quality challenges?
Definitely, yes. We have introduced new type of reserves as an example. We call it rocket reserve. So it's really automated reserve which reflects on changes on power generation as an example. Maybe the biggest challenge in Nordic area is the inertia, which is getting lower and lower because we are getting rid of the conventional energy generation and the inertia is pretty low, and of course the risks increase also within some smaller breakouts or whatever is happening there on the grid. So risks are bigger, but we have actually created pretty intelligent solution to manage the low inertia. It's based on AI. So learning process, we share the solution between 4 TSOs in Nordic area. And based on history, there is very deep machine learning on the condition in the near future. We are able to provide for the future big changes, and actually during last summer there was the lowest inertia happened in the history, but due to the new solutions we were able to provide our operators with very fast power generation, so that we were able to cope with the very, very serious situation. So it has couple of times happened now that the inertia has went low. There are maintenance of power plants and so on, so the risks are also bigger, but however, these new solutions seem to be pretty good. But you really need the capabilities to have the data, have real data, and also rely on the data that we are able to automate the control of the grid. So of course there are very big risks as well, but you need to rely and trust, and of course you need to control also. But however, I see that the system is going towards more automated solutions all the time, so very good experiences already.
That's fascinating to hear that you guys have already been using big data and machine learning to think about the problem of inertia. And also a fabulous step that, I hear what you're saying about trust, that you have to take that trust and you have to take the step. And it sounds like you guys are very much in Theodore's boat, which is we're going to do this digital thing. Theodore, you guys don't have so much renewable, but do you have power quality challenges as well?
We have power quality challenges as well, because we have a small grid with low inertia, but then we are using wide area control smart grid to help us when we have problems. But our main focus now is how to, like in digital substation, how to measure power quality, because then you have to have a higher sample rate. Where to put all this data? Should we put it on the process bus, or should we do something else? And this is what do you call it? In the future, we have to find out how to, in the digital substation, how to measure this power quality issues.
Mm-hmm. Yeah, absolutely. And I guess the challenge of where to store data and how to store it, and and then what to do with it will be something that will be solved by everyone together, and by sharing, I guess, experiences like this.
Yeah.
So that's really interesting. Ralph, what's your views on how digital and digitalization of HV switchgear in particular will be able to help with issues like this?
Yeah, we from Hitachi ABB Power Grids, we are expecting that power quality challenges will increase in the grids around the world, mainly up to 420 kilovolts due to the renewable power generation, or let's say in terms of wind parks or solar farms. So that's one thing what we see, but also because there are higher grid control demands on the operation side. So these are the reasons why we believe and we see that this requirement will increase. We see low power instrument transformers as the sensor technology as the key in this area for gas insulated and air insulated solutions. And of course, those, let's say, low power instrument transformer, they need to be, let's say, enlarged to measure power quality. This could even be more enlarged to go beyond power quality. So we can think about a lot of things, but first let's do the homework. So let's focus on development of low power instrument transformers providing power quality measurement in a reliable way. Combine this with protection and metering to get compact designs, and using the digital technology to measure the data, to communicate the data, and finally to store it, and then we can also analyze. And this will help, let's say, just my vision, if we have more or less in each point a low power instrument transformer in each connection point, the grid control and all these effects will be known first of all, and then we can do something with it, and then we help the operation of grid, of course, to eliminate it as well.
Yeah, fantastic. Thank you.
Mike,
Thank you.
I have one question to Ralph. Do you think the technology you're using for low power transformer is changing? Do you think you are going to use the light for measuring, or just the Rogowski coil?
No, let's say the technology we are using today will not change. What we do is mainly to work on the electronic performance and capabilities to enable more, let's say, sampling rates to enable more performance-related topics. So today's technology, what we have, has a limitation in this area, and this is where we work on to enlarge it. We don't plan to change the measurement sensor technology from Rogowski coil or capacitive divider. It's for us, what we see right now, it's adequate, and even going beyond the power quality, it would be still adequate also.
Thank you. Thank you. Great question, Theodore. So just a couple of questions really left. Something that's occurred to me is that you guys are really committed to this digital journey, to this digital transformation. And we talk about net zero 2050 and lowering our carbon output and all of that. Do you think that there's anything particular, Kari, in the first instance, do you think there is one barrier to digital transformation, or do you think that you guys are kind of going at the speed that you would like to at the moment? What's your thoughts on that?
I don't see kind of barriers as such. Of course, I see that we really need to do lots of cooperation together, because it's not only TSOs as such who can do the things, because in the future we are building kind of ecosystem where TSOs are connected, DSOs are connecting, power producers are connected, power users, and then other type of service providers are all connected together. So we really need to do this whole renewal of the whole energy system together. And maybe that involves creating some standards and some kind of framework where we build this whole structure so that we are not doing things isolated in silos. So very deep cooperation together is required. That is, I think, one of the most important things.
Fantastic. So it's about the whole energy system rather than companies in isolation. Yes, superb. Right. Thank you, Gary. And Theodore, any particular obstacles or barriers to your thoughts about digitalization?
No, yeah, maybe we, like I said, it's because energy sector is very conservative. It's hard to change. We have people that work in the energy 20, 30, 50 years, and they are just, why change something that is working? And I like when they say they see the light. I have one colleague, and he has seen the light, and he is optimistic what this can be, and he is always now challenging us, the new engineers. Can we do that? Can we do that? We can do that. We can do everything we want if we have the digital measurement and everything. So I think it's getting the people on the boat to the digital, and they see what we can do and what the data that we have, what we can do with it.
So it sounds like you're really changing hearts and minds over there in Iceland,
Theodore. It's just like telling old people to buy a smartphone.
Of course. And we all have them now. We all have them now. Very good. Okay, so just the last question to you guys, if you don't mind.
Maybe Sam, just to add here, I mean, beside the human factor, I think interoperability and also cybersecurity are the two key elements to, let's say, come more to, let's say, global cooperation. And of course, these are technology-wise were also obstacles in the past. Yeah, so going back 20 years, these were obstacles, and let's say this is one task for OEMs and also utilities and customers to work on that, to come to a real common platform beyond IEC 61850 communication, for example, to enable that.
Sure. So we can get to a truly secure Internet of Things, as you guys have been talking about across your substations, your digital substations.
Yeah.
Super. And so staying with Theodore, or going back to Theodore there, when you've managed to make the whole of Iceland digital then, what do you think your business looks like? What does the operation look like in, say, 20 or 30 years? When the digital transformation has happened, what will be different, and what would your business look like?
I would come to work and open my computer and have some message that you have to do something there and there. And I think, like, we can take an example, when you're taking out a line, we have to have operators in the substation, and we have the control center. They have to manage to open each break or each circuit. And I think thinking in the future, we just press one button and the line is out, and we get confirmation that the line is out, and then we have the earth connectors in, and we may work. And I think when we have this maintenance data that we don't have outage because something is break, because we did know it before.
Okay, so predictive maintenance.
Yeah. And we have, like I say, we have AI that is helping us control our assets, what to do, and I think in 20 years we are not. It's very easy to come to work after 20 years. I hope
Sounds
so.
Great.
I hope so.
I hope so. And Kari, how about you? How do you see the future of the digital transformation in Finland in 20 years' time then?
I fly a little bit higher, so we have been able to do our strategy so that Fingrid is enabling the carbon-free environment in Finland, so that we have been able to build the connections so that we are able to have the maximum capacity from wind power. So, and we are not importing power anymore and relying on import power. We are actually exporting lots of power to Sweden, to Estonia, to our neighbors. And we have also able to attract new businesses like new data centers, youth data centers, new power to X industry to Finland, because we have reliable wind power, we have reliable renewable power available, we have good system to keep the availability of power in Finland. We have one price area, so it's very attractive to industry. And also the conventional industry has changed to renewable energy, so that we really say that Fingrid has enabled the green environment in Finland, carbon-free environment in Finland, and Fingrid has done it.
That's fantastic, Kari. So it's really about, it's not just about the net zero transition, but it's actually about improving the economy and inward investment for Fingrid.
Exactly.
Wow, that's lofty ambitions and very exciting. Very exciting.
Yeah.
Ralph, what about you? What do you see the sort of digital landscape for our customers in 20 years' time?
I think in 20 years' time, it will be very normal that we have the sensors to measure everything what can disturb our grid control in any point of the grid. We know at every stage, like Theodor described, more or less on our working laptop, we know exactly the situation, the status, and what to do information. We can analyze historic data more or less endless to go back and say, okay, here we had a problem, what to do with it. So we have machine learning models to work on that. And finally, I think it will be very normal to just call a collaboration or a service center. I have a problem, I cannot operate a circuit breaker, and we will use augmented reality and other methods to very quickly solve the problem. I think that is one of the most important topics what we provide to solve problems fast, so that the disturbance is very small.
Excellent. So no need for you to go out in your Land Rover, Ralph.
No.
Good stuff. Okay, well, look, thank you so much for your time today. That's been a fascinating discussion, Theodor, Kari, and Ralph. I hope that everybody else has enjoyed it as much as I have. We certainly heard a lot about data, about how to deal with data, and about how to make quick decisions. We've heard some real life examples from what Theodor and his team are doing in Iceland with digital substations, and what Kari and his team are doing in Finland to move towards grid of the future. If you've enjoyed this panel discussion, I really hope that you'll join us for some others. We have quite a lot going on these 2 days. In particular, smart applications for HV switchgear, or digitally delivering the service experience, or perhaps you'd be interested in digital switchgear, the key to higher productivity and reliability. So for the meantime, thank you very much from all of us and from Hitachi ABB Power Grids for joining, and we'll see you soon. Thank you.